Okay, so in this video, we're going to be dealing with finding the domain of rational and square root functions. So what we're looking at right here is a rational function, and then the next problem will be a square root function and so on. Okay, so I have 4 problems here, and the first one again is going to be a rational function. So how do we find the domain of this function? Now, when you're dealing with a rational function, it's very easy to find the domain. All you have to do is look at your denominator. So for example, I'm looking right here. Okay, and whatever's going to make your denominator 0 cannot be part of your domain. Okay, so if you were to graph this rational function, you would see the various curves of this function, and you would see at a particular x value, it's going to be undefined. And where it's undefined is actually going to be where it makes your denominator 0. You'll have a vertical asymptote there. Okay, and if you don't know what an asymptote is, that's simply an imaginary line that the curve is approaching but not actually touching. Okay. So to keep it simple, we just want to find the domain here. All I have to do is take my denominator and set it equal to 0, because again, we know that whatever x value is going to make this denominator 0, it cannot be part of my domain, because again, that will leave me with division by 0, which will make it undefined, meaning it can't be part of my domain. So for example, all you got to do is take your domain, set it equal to 0, and solve. So 2x minus 1 equal to 0, and solve it, right? So here I'm going to add 1 and divide by 2. So I get x is equal to a half. So your domain here is going to be all real numbers except x cannot be a half. Now, I always write my domain in interval notation. If you don't know how to write it in interval notation, I have a video on that. I'll go ahead and link it below. But again, you could write it this way here, like all real numbers, right? Except x cannot be equal to a half. That would be fine, okay? But again, I want to write it in interval notation. So when you do that, you always go from negative infinity to positive infinity, or in other words, least to greatest. So I'm going to start at negative infinity, and I'm going to use a parenthesis because I cannot be on negative infinity. And then I'm going to a half, okay? Now, can I be on a half? No, I cannot be on a half, because if I am, that will make my denominator 0. So I'm going to put a half here, but instead of putting a bracket, if I put a bracket here, that means I can be on it. And I don't want to be on it because, again, that will make it undefined. So just like I did with negative infinity, I'm going to use a parenthesis, okay? So interval notation is pretty straightforward. You're only dealing with parentheses and brackets. So if you have a parenthesis, you're going right up to it. So for example, your infinities will always use a parenthesis because you can't be on it. And then a bracket is when you are actually right on it, okay? Meaning you can include that value. So again, what I'm saying here, I'm going right up to a half, but I cannot include a half, right? Now, you have an asymptote here. So again, if you were to graph this function, you would see that you have this vertical dashed line that's imaginary that the curve is approaching, meaning I have a gap in my solution here, okay? So to show that gap, I use something called a union, all right? So I just put a U here. That U is telling me I have a union there, meaning I have a vertical asymptote. There's a gap in my solution to my domain, and that's how I show it. And then I just continue on. It goes from a half to positive infinity. So again, I cannot be on a half, so parentheses, and then comma, to infinity, close it with a parenthesis, and then you're done, okay? So here it is. So there's the domain in interval notation, and that's how we're gonna do all of these problems, okay? We're gonna write it in interval notation. All right, let's try our next example. So here's our next example. This one is not a rational function. This is a square root function. Okay, so whenever you're dealing with a square root function, it's a little bit different. And essentially what you want to do, you want to take your radicand, which is the part underneath the square root, okay, the part underneath the radical. And what you're going to say is you're going to say that 5x minus 1 has to be greater than or equal to 0. And we're saying that because if for whatever reason this part in here is negative, that means I'm going to be dealing with an imaginary number, and I do not want that. So from here, all you have to do is solve, right? I'm going to add 1 and divide by 5. So I'm going to get x is greater than or equal to 1 over 5. That's my domain. You could literally leave it just like that, right? X has to be greater than or equal to 1 over 5, or 1/5, right? And so putting this in interval notation, right, I'm going to use a bracket here. And I'm going to start at 1/5. And now I'm using a bracket because I can be on 1/5. Because look, it's equal to. I can see that right here, greater than or equal to. So in other words, if I were to plug in 1/5 into this inequality here, I'm going to get 0 is greater than or equal to 0. And that's fine. That's true, right? So we're using a bracket indicating that we are right on 1/5, and then we're going to positive infinity. So comma, positive infinity, and then close it with a parenthesis, all right? And that's done, okay? And so again, when you're writing the domain, it's always in respect to the x-axis. So again, these values are pertaining to the x-axis. That's what we're talking about here, right? So on the x, we're going from 1/5 all the way to positive infinity. Okay, so now let's go ahead and try 2 more examples. These are going to be a bit more tricky. So here's my next example, and this one here again is a rational function. Now look at your denominator here. We're going to do the same thing we did before. We're going to take that denominator, set it equal to 0. That way we can determine what x values are going to make this undefined. That way we can make sure not to include them in our domain. So we're going to take our denominator, set it equal to 0. I get x squared minus 2x minus 3. Set it equal to 0. I have a quadratic here. I can factor that, right? And I'm going to factor it using the AC method. So a times c. That's going to be 1 times -3. I get -3. 2 numbers when I multiply, that will give me -3, but add up to my b, which is -2. Well, that's going to be -3 and +1. So again, when I multiply them, I get -3. When I add them, I get -2. And again, that is factoring using the AC method. I'll go ahead and drop a link below for a video that I did on that as well, if you don't know how to do it. It's a very mechanical way of factoring, and it's the way that I factor quadratics. I find it to be the most beneficial and the most straightforward. There's no guessing and checking, okay? So now that a is equal to 1, I can put it right in factored form. Again, my coefficient in front of x squared is 1, meaning, again, I don't have to factor by grouping. I can put it right in factored form. So I'm going to say here x minus 3, and then x plus 1, and then equal to 0. And from here, you just solve each one of your factors. So you're going to say x is equal to 3, and x is equal to -1. So again, if you wanted to, you could just say, okay, my domain here is going to be all real numbers, except x cannot be equal to 3, and x cannot be equal to -1, right? That's fine. You could write it like that. But I want to write it in interval notation, okay? So when we go in interval notation, we always go from -infinity to positive infinity. And again, this is in respect to the x because we're talking about the domain. So I'm going to say here in parentheses, -infinity. And then what am I going to? Well, I'm going to this -1. Now, can I be on -1? Well, I can't, because if it's -1, I just proved it out right here. It's going to make the denominator 0, right? So I'm going to put -1, but I'm not going to put a bracket. I'm going to put a parenthesis, okay? And then what happens? Well, remember, wherever it's going to be undefined, you're going to have a vertical asymptote there, meaning you're going to have a gap in your solution. So now I put a U for union, okay? And then I continue on. Now what do I do? Well, I'm going from -1 to +3. And again, I cannot be on those values, so we're going to use parentheses. And I'm going to say -1, comma 3, close it. And again, this 3 is indicating I have a vertical asymptote there because it will make it undefined, meaning I have another gap in my solution. And then finally, I go from 3 to positive infinity. So in parentheses here, 3 to positive infinity. And this one is now done, okay? So this is what your final answer would look like in interval notation, all right? And that's done. Just don't forget to include the unions if you have a gap in your solution, all right? All right, let's try one more example, this time with a square root function. All right, so here's a more challenging square root function that we're being asked to find the domain on. We're going to do the same thing. We're going to do 3x squared minus 3x, and we're going to say this part here has to be greater than or equal to 0. Again, I'm just pulling out that radicand, and I'm saying that it has to be greater than or equal to 0. Now from here, you actually want to solve for x. So you could leave this inequality here and just solve for x and know that you're just looking at the x values. But I'll go ahead and replace it with an equal sign because, again, we are technically solving for x here. So I'm just going to say here 3x squared minus 3x equal to 0. But this right here is what we're going to use at the end to check, right, our x values. Okay, so keep that in mind. So when I put the equal sign here, I'm just doing that because I want to solve for x. Now, you can actually solve this by factoring. I can pull out a greatest common factor here. I can pull out a 3x. If I pull out a 3x, I get 3x, and then in parentheses, I get x minus 1, right? All equal to 0. And so now I have two factors and I can actually solve both of these factors. If I do 3x equal to 0, that means x will be equal to 0. So x is equal to 0. If I solve the other factor, I get x minus 1 equal to 0, meaning x will be equal to 1. So x is equal to 1. And so again, if I only had one x value here, I could have just left this inequality here and solved the original. But since I knew that I was going to have two x values, and I knew that because I was dealing with a quadratic, again, I put an equal sign here and solve for both of those x values. So from here, what you have to do, you have to take these x values and you have to plug it back into this inequality, the original one, to see if it's going to be true. And so essentially what you're doing, you're picking test regions, okay? So if I were to put on a number line real quick, we're going to have three test regions when we do it. So for example, your x value here is going to be 0. So I'm going to put 0 here on the number line, meaning everything to the left of 0, we're going to call region 1, okay? And then you have this 1 here. So I'm going to go ahead and put 1 on. And so now you can see that I have two more regions. I have the region in between 0 and 1. I'll call that region 2. And then the region to the right of 1, that's going to be region 3. And so what you want to do here, you essentially want to pick numbers in each one of these regions and test it in your original inequalities, see if it's going to be true. And you'll see how this will work out. So for example, I want to pick to the left of 0. I'll just pick -1. So if I plug a -1 into this original inequality, will it be true or false? Well, let's check. I'm going to do 3 times a -1 squared minus 3 times a -1, and this will be greater than or equal to 0. Well, this ends up being +1 times 3, I get 3. And then the two negatives, when I multiply, make a positive, so I'm left with +3 greater than or equal to 0. So again, that is 6 greater than or equal to 0. That is going to be true. 6 is greater than or equal to 0. So what I'm going to put here is T for true, okay? And then you'll see why we're doing this. At the end, we'll put it all together. So I just want to test the last two regions down. So now I have to pick a number in between 0 and 1. I'll go ahead and pick a half, okay? So if I plug a half in, what happens? So I get 3 times a half, and then square it, and then minus 3 times a half, and then greater than or equal to 0. When I do this, I get 3 times a quarter, right, minus 3 over 2, greater than or equal to 0. So we know that 3 times a quarter is going to be 3/4 or 0.75. So it's 0.75. And then we have minus 3 over 2. That's going to be minus 1.5, writing it as a decimal, greater than or equal to 0. So we know that on the left-hand side here, that's going to result in a negative number. And in particular, it's going to be negative 0.75. So negative 0.75 is not going to be greater than or equal to 0, meaning region 2 is false. That does not work. So now we have to test region 3, and then we'll be done. And I'll show you how to put it all together from there. So I'm going to scroll down a little bit, that way I have room. And so now I'm going to test region 3, pick a number to the right of 1. I'll just pick 2. So I'll do 3 times 2 and then square it, minus 3 times 2 and then greater than or equal to 0. When I do that, well, I get 4 here times 3, that will give me 12. And then negative 3 times 2, that's negative 6. Greater than or equal to 0. 12 minus 6 is 6. So yes, 6 is greater than or equal to 0. That is true. So I'm going to put true here. Okay? So what we're saying here is that our domain is true for all values to the left of 0 and all values to the right of 1. But it's not going to be true for these values in between. Now remember, I can actually plug in 0. If I plug in 0, yeah, that will make this inequality true here because it's equal to. Same thing with 1. If I plug in 1, that will make this inequality true. So I want to write it in interval notation. So again, in respect to the x and going from negative infinity to positive infinity, I'm going to say the following. I'm going to say parenthesis negative infinity, and then I'm going to what? Well, I'm going to this 0 right here, okay? And can I be on it? Yes, I can. We just talked about that, so I'm going to use a bracket. Now look, you have a gap in your solution. Region 2 was not true, meaning you have a gap there. So what do we put? We put a union, okay? Just like we were doing with the rational functions, right? And then I go to region 3, I start at 1. Can I be on 1? I can. We talked about that because it's equal to, right? So I'm going to use a bracket here, 1 to infinity. And then again, close it with a parenthesis because again, you cannot be on the infinities. So this is it. Here's my domain in interval notation. All right. And so that's pretty much it. I hope that you learned something from the video. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.